Hello everyone, welcome to the first little episode here of Femboy Statistics. I'm gonna just run you through one of my old little projects here and just see if you can pick up one or two things about the R language and about statistics. R isn't, while it's not too common of a language, it's pretty similar to Python, so I'm sure you could pick it up pretty quickly, or ask Femboy coding about it, maybe he can tell you a thing or two. But I like it because it has a lot of statistics tools built into it immediately. So this little project is based on verifying the central limit theorem, which states that any exponential distribution can begin to look like a normal distribution given sufficient sampling. With that in mind, I'm going to use a WHISKY dataset. This is a graph of the review scores of 2,000 different Scotch whiskies, and on the vertical axis is the frequency at which a whiskey received that review. So these whiskies come from different price ranges, different regions, different ages, and different qualities, of course. What we can see in general is that very few reviews got in the 60s and 70s, very few got into the high 90s, and most of them are located in the high to mid 80s. So what we aim to do is to focus in on this distribution a bit and find a sufficient mean and sufficient sampling so that we can get this exponential distribution to look more like a normal distribution. Shouldn't be too hard, right? So, why do we want this to look like a normal distribution? Well, there's a bunch of really neat statistics that can be done with a normal distribution. Most importantly is once you have the central point of a normal distribution, the mean, you can figure out where other bits of data lie. So once you have the mean, you can say, if it is a normal distribution, that 66% of the data lies within one standard deviation of the mean, 95% lies within two standard deviations, and 99.7% of the data lies within three standard deviations. With that in mind, we want to see if a high reviewing Scotch really matters, in the sense that if I get a Scotch with, what's this, about an 86 out of 100 review, that's not very exceptional because lots of them got it. But how high or how low does a Scotch review have to be for it to be considered truly good or truly bad? So let's get on to our methodology. What we're going to do here is we're going to take a sample of Scotches. So here in our second plot here that's running, we have got a bar shelf. We're calling it random bottles, and we're going to take 100,000 random bottles from the review dataset, and we're going to make a histogram of the reviews that we get. We might pick the same bottle more than once, we might pick all different bottles, and you can see that most of the bottles are in that high 80s range, and we would expect that because most of the reviews lie in that. But now, let's suppose instead of each time we reach up to the shelf and take one bottle, we actually take two bottles and record the average score of the two bottles. So, for example, if we picked a Scotch with 80 and a Scotch with 85, the average of that would be 82.5. And you can see the distribution actually narrows. You can see in our first one, the reviews range from 65 to 95, but when we take the average of two samples, the reviews only range between 70 and 95. The review narrows the more bottles we take in each sample. So let's scale this up a bit. A little bit of this is just some syntax we don't need to worry about. I've got a matrix here that represents a random sample of bottles many, many times over. And what we're going to do is we're going to get a histogram. We're going to get 5 bottles off the shelf, 15 bottles off the shelf, 30 bottles, 50, and I did 50 again because I'm a bit of a silly. And we're going to get the average of each of these rounds and get the frequency. So when we take 5 bottles off the shelf and get the average, again, the distribution becomes narrower, between 80 and 90, focusing a little bit more in the high 80s. We take 15 bottles and it's beginning to really look like a normal distribution with that large central bulge. Moving to 30 samples, again, look at the bounds of the distribution. It narrows. And then finally at 50 samples is when we see it probably approaching diminishing returns, I should say, if we go any higher than this, where we go from 84 to 89 with a clear central peak Isn't that interesting? And let's just plot a normal distribution line on this just to sort of give you an idea. You see that we've got this one central peak here, and then everything either side of it is symmetrical. So, what does this tell us? Well, our data here has a mean of 86.7 and a standard deviation of 0.57. What I am saying using this normal distribution is that 66% of all whiskies in the dataset will lie within 0.57 of this mean of 86.7. So most bottles will be in the range of, say, 86.2 to 87.4. And then 95% of the bottles in the whiskey set will be between two standard deviations of this. So that will be 86.7 plus one standard deviation would be about 87, and then it'll be 85 going down the way. And then almost all the bottles, 99.7% of them, are accounted for within plus or minus 3 standard deviations, or 3 sigma. And so with this, we can actually come up with a little bit of a meaningful conclusion. If you wanted to buy an exceptional bottle of whiskey, then you would be looking for something that is 3 standard deviations higher than the mean. In this case, our mean of 86.7. 3 standard deviations is 1.5 of that. So, you'd want to be picking up a bottle that's in the 90s if you wanted to get something really special. Similarly, if you wanted to get something really terrible, you'd want to get something that is outside of 3 standard deviations. So something in the less than 84 range would be considered a below average bottle, an exceptionally below average bottle. Well, that's all I have to say on whiskey. I hope this has been a little bit of an interesting intro and given you a little bit of an insight into some of the fun things you can do with data science, statistics, and the R language. Thank you, and I'll see you next time.